So, thank you for joining the session named Bringing Open Source Communities Together Cross-Community CI, which I prefer to call it XCI because it is too long to talk about. My name is Fatih Dermenci and I work for Ericsson, based in Stockholm, Sweden. And I'm 100% open source developer. I mainly worked in OPNFV and I have few contributions to OpenStack and some other open source projects. But I mainly work with OPNFV infrastructure, CI/CD, and so on. And also I am the project lead for OPNFV release engineering project. And this talk I will try to give you some idea about what this cross-community CI effort or initiative is, because it was part of the keynote as well, which made us very happy, which told us that this is a common problem. It's not just about OPNFV, but larger ecosystem, and it made us happy because we want to work with others. So what I will talk about during this session is the problem we have been trying to solve since the inception of OPNFV, the things we tried and sometimes failed, and the new things we started trying out, our progress, and where we are today, and finally where we want to be in near and long term. So before going to details of XCI, I can perhaps talk about what is network functions virtualization shortly. As we all know that current networks are mainly built using purpose-built hardware, software, and they are pretty tough to evolve, transform, and they, of course, they serve their needs, our needs, but it is very hard to implement new features, bring new services to users, and enable developers to innovate. And based on similar concerns, Etsy came up with this network functions virtualization concept about 5 years ago and released a white paper. Mainly major operators came together and talked about how they can change how the networks are built, developed, built, and deployed. And based on those conversations as part of OPNFV string group, this type of architecture came up. And in this architecture, it's basically, it requires switching from purpose-built hardware to open hardware, purpose-built software to open source operating systems, and then you can simply put applications on top of it, enabling open and industry standard virtualization platform for telecom functions. And this basically makes it possible for open source communities to come together and bring up new features much faster than vendors can do, and enables the innovation so people can develop things in much easier way. This essentially optimizes service creation and activation and assurance by bringing cloud world into telecoms and basically making everything faster. This is, of course, driven mainly by standards, but most of you probably know standards work takes years to come to conclusion because all these vendors, operators, they need to come to an agreement and agree on how the things should be done to enable network functions virtualization. Based on these experiences, about 3 years ago, the project named Open Platform for Network Functions Virtualization was established by, again, few operators and few vendors and hosted by Linux Foundation to make it even faster to realize the next generation telecom networks based on cloud and virtualization. And as you see there, the description, and this is what you will see if you go to OPNFV website, it's basically career-grade integrated open source platform to accelerate the introduction of new NFV products and services. So this is, 3 keywords there, career-grade. OPNFV aims to solve telecom issues mainly. So it needs to provide what telcos require. Probably you heard this many times, 5 nines. You have 5 minutes downtime a year, something like that. So that is one of the things OPNFV is pursuing to see if these open source components fulfill those requirements. The other one is, okay, you have multiple different open source components, but who is integrating them? Mainly vendors, and no one in open source really doing this integration work. So the second aim for OPNFV is to create this integrated platform. And the third one is, obviously, it must be an open source platform so everyone can go and contribute and take it back to their companies and look at it and create their products based on this reference platform. So in the end, OPNFV tries to come up with a reference platform for NFV so everyone can take a look at and implement NFV based on these things. And obviously, OPNFV takes input from standards bodies. It's not just open source, but we work pretty closely with ETSI NFV, and we bring their TSD work group output into OPNFV to realize what they have been working on. So this is a long explanation about OPNFV, but in short, OPNFV is system integration and test done as open source project. So you see many open source projects components on this diagram, and what we do in OPNFV is basically bring all these different open source components to OPNFV, integrate them, and test them together as a system and see if they work. And if they don't work, we go back to relevant upstream communities and talk to those communities saying, okay, guys, we tried this, but it doesn't work. We should fix this. And then we just don't stop there and ask, this must be fixed. We also go back to those communities and fix them there directly. Apart from fixing bugs or issues, we also bring in new features from ETSI or other standard bodies back into these upstream communities. And this basically makes OPNFV an upstream project. We directly work in upstream, and we don't keep too much source code in OPNFV itself. And all the development work goes back to upstream communities. The other thing about OPNFV is that we work with stable versions of upstream components. For example, we made our latest release 2 weeks ago, I think. It's named Euphrates, and it used OpenStack, Okata, Open Daylight, Carbon, I think. So we pull down stable versions back to OPNFV because we want something that is proven to be working by upstream communities so we can take them and attempt to integrate them. And this actually helps us and our users, developers, and other communities to see their output in different setup as a whole, as a system, and get feedback from this end-to-end integration and testing activity. This is kind of an XCI, actually. So we have been doing this cross-community continuous integration since the day one, since OPNFV first was established. But using the stable versions kind of helpful in certain cases, but it is slow if you look at things from our side, which I will talk about it later on. But the main thing here is we directly work in upstream. We don't keep any source code in OPNFV except test cases or infrastructure or CI/CD stuff. And we do end-to-end system integration and testing. Now, I've shown 20 whatever open source components there, how we put them together. So first thing, we need to have some machines. They could either be bare metal machines or virtual machines. We first need to provision those machines, and we do that using 3 different Linux distributions. We support Ubuntu, CentOS, and OpenSUSE. Once we provision these machines, we need to bring OpenStack or Kubernetes on these machines because those are what our virtual infrastructure managers. And we do installation of these different cloud execution environments using different upstream installers. For example, we have TripleO, we have Mirantis Fuel, we have Daisy based on Cola, 5 different installers in OPNFV. And these installers support different features and different distros. So we pick one of these installers during our CI daily runs, for example, and that installer puts OpenStack on provisioned machines. And we don't stop there. We then replace Neutron with Open Daylight or ONOS or Open Contrail, and we try to see if this combination works fine or not. And if we find something wrong with it, we go to relevant communities and get those things fixed. And we don't stop there either. We have some additional features like service function chaining, BGP VPN, or KVM. For example, we replace KVM from compute nodes and put an improved version of KVM for telco-related stuff. And finally, we start testing this. We run functional testing and we run platform benchmarking to see if the composed platform works fine or not. And this is really pretty complicated if you think how many different combinations you can have there. For example, during our last release, we had more than 50 different combinations. Because we have 5 different installers, they can either deploy, they either need Ubuntu, CentOS, or OpenSUSE, then they support OpenStack or Kubernetes, and then they support different SDN controllers. So it's exponential growth in number of scenarios. And if you look at our first release, we only had 2 scenarios, OpenStack, vanilla OpenStack, and OpenStack with Daylight. And now we have more than 50 scenarios. And it is not a simple thing for us to fix this alone. That's how I will tie this to OpenLab, for example, in the end. So we continuously bring these different versions or different variations of composed platform and test them and see what works, what doesn't. And in the end, we release our scenarios as part of OPNFV releases. For example, you release OpenStack Okata, we take it, we put OpenStack Okata together with Open Daylight, Carbon, and whatnot, and then we release it after you release your version in OpenStack side. And obviously, this is nearly impossible or totally impossible to do that manually. We need some kind of automation in place. That's why when we first start talking about what to do with OPNFV, we directly start talking about, okay, how we can automate bringing this composed platform up and running and then test these things automatically. And then we started thinking about how we can fix our CI, and we came up with this pretty picture, which has Jenkins in the middle and many different labs distributed all around the world. And then we use some tools from OpenStack Infra, basically Jenkins Job Builder, to create our jobs and distribute our jobs on different labs all around the world. Now, I must talk about our bare metal labs here, because that is one of the good things about OPNFV. We have many other good things, obviously, but the Pharos labs are our bread and butter, because without this hardware support, we can't do anything, because we do things on bare metal. We use virtual machines as well, but they are mainly used for developer near loops, for example, for health check, smoke test type of stuff. But our real testing activity is done on bare metal machines, and those machines are donated by different vendors, member companies in OPNFV. In US, we have Intel, we have Linux Foundation. In China, we have Huawei. In Japan, we have Okinawa Open Labs. And obviously in Europe, we have Ericsson and Nokia. So all these companies donate machines to us, and we have to use them in the right way. And we have been able to do that, but obviously this doesn't scale anymore. One of our bottlenecks is how to manage and properly use our hardware infrastructure. And we are thinking of solving this problem with Zool V3 in future. So we have 14 labs, and we run different testing activities on these labs. Apart from having this huge number of nodes in these labs, we also have very varied type of hardware in these labs. Okay, we use 6 node bare metal pods. One of them are jump hosts, 3 of them are control nodes, 2 of them are compute nodes. But these hardware are different from each other. Some have Dell, some have HP, some have OCP hardware. So we can see how our composed scenarios behave on different type of hardware. So we have different type of benefits getting from our labs. So we have more than 200 bare metal nodes utilized by our CI, and we support both x86 and ARM architectures. As I mentioned, during last release cycle, we had more than 50 scenarios. we deployed OpenStack more than 8,000 times in 6 months. I don't think you deploy OpenStack that many times because that's not your concern. But for us, deployability is one of the things we have to ensure. Okay, we can deploy OpenStack, but can we deploy OpenStack with OpenDaylight or with Fido or whatever? And we did this more than 8,000 times. And for OpenDaylight, for example, we deployed OpenDaylight for more than 4,000 times, I think. So we deploy things many times, and we try to break what you develop. And in the end, we come back to you and issue bug reports or feature requests and try to contribute those back to OpenStack community. But now I might sound like I am telling how great we are. We are good, but we can be better. And this is actually related to what I mentioned in the beginning. We are using stable versions of upstream components, and we directly work in upstream. So assume you are committing code for Neutron now, and your code gets tested by OpenStack CI, and you need a few months for that code to become part of Queens, for example. And for us, we need to get stable version from OpenStack, so we need to get Queens once you release in March or whenever. And then once we get Queens from you, we spend 6 more months to integrate that with OpenDaylight, for example. It takes us to 12 months, which basically means that the contribution I make today will be tested and released next year these days. Then you will hear from us, guys, this didn't work. So it is very late. Probably even that developer have forgotten that contribution because it's 1 year, a long time. Maybe that developer is not even around anymore. So the problem we are having now is we are very slow, and the communities we are working with are very fast. So we are always trying to catch up with you. That is not sustainable, and that is actually at the same time annoying developers because developers want to see things pretty quickly. And if we tell them, sorry, you have to wait a year, no one will do that. And they are not waiting. They are basically sometimes having enough of this, and they move on to some other things which might be faster and more fun. Apart from that, since we are always late providing feedback to you, the quality of our Compose platform goes down because we can't get those fixes implemented quickly enough. That builds up, and sometimes some of those things can't be even fixed because it's not relevant for you anymore. You don't care sometimes what type of faults we found there because it's too late. And that takes the quality of Compose platform down as well. And this is where we are today. Our second release had the greatest quality, perhaps, because we had less number of combinations and we were a bit faster. But over time, we increased the combinations, and our pipeline times went up to 36 hours. One loop takes 36 hours because we have, like, for triple install, for example, 25 different scenarios, and it takes 2 days to run and give feedback, just the first health check type of feedback. And this takes quality down as well. And based on these things and the feedback we got from OPNFV and other communities, we started thinking what we can do, how we can improve our lives, and how we can be more useful to our upstream communities. And we started talking to a few people from OpenStack Infra during Austin Summit, I think, Colin Murphy, I think, and she told us to look at some tools, for example, Puppet Infra Cloud, to see if we can consume OpenStack from master. And that's how we came up with this, the benefits of end-to-end integration type of talk during Barcelona Summit last year. And we basically described our problems and the need of directly going to master branches of upstream projects and started our prototypes based on what we heard from you guys. And we started this with Bifrost and Puppet Infra Cloud, and later on we changed Puppet Infra Cloud with OpenStack Ansible, but we start this activity, and this in turn turned into cross-community CI. Because initially we called this third-party CI to OpenStack because that is what you use in terminology. But what we are doing is a bit more than third-party CI because we are trying to do this thing for all the communities we are working with. Because of that, we needed to differentiate this and we need to tell other communities, okay, guys, we are doing this for all these different communities and whatever we are doing for OpenStack might be relevant for you as well. For example, Open Daylight. So this is cross-community. You will get these benefits from this CI system as well. And our first communities we work with were OpenStack and Open Daylight. And we had some progress with OpenStack and Open Daylight, obviously. And then we start with FIDO community, and we will start working with ONAP in future. So this basically means that, okay, stable versions are good. We have some users who are after stability. But we also have some users and developers who want things faster. For example, we have some academical institutions member of OPNFV, Sanjan from Canada. They want to have latest versions because they are not operators. They can bring in latest versions much frequently and see how the things work fine or how the things look like when they put together. Because they are kind of research institute. They are more interested in what's happening now to do their work. So based on this, we start a second track in OPNFV, which is called latest track, which will bring down master branches, master versions of all the upstream communities we are working with, put them together and apply same principles. Okay, we create this composed platform, which is OpenStack and Open Daylight, and we run testing against that platform and see what works and what doesn't. And this essentially results in much faster feedback. We made a calculation, and in worst case, as I mentioned, it could be 13 months in stable track. And in worst case, in this latest track, it could be about a week. So from 13 months to a week is pretty big improvement. And apart from improving the feedback time, the feedback we provide you will be relevant. So you will have interest in fixing that problem because it might be valid for other users of OpenStack as well. And then we started creating some pipelines. So this is an example diagram for these 3 selected projects. And what we are going to run against or for these upstream communities differ between each other because not all the open source projects are mature. Some projects like OpenStack, they are pretty mature. You are doing things pretty good way and you are improving all the time. But some of the other projects are pretty young. For example, ONAP, they haven't even done their first release yet. So they are trying to fix their infrastructure and CI/CD. And when we go them now and say, okay, we want to run voting jobs against your stuff, they will say, go away. And that's what they are saying, essentially. And for Open Daylight, for example, if you go to Open Daylight, they say, yes, give us more feedback. So the first thing we want to do is basically provide patch set level feedback for few components of each of these projects. For example, for OpenStack, we started doing this for Bifrost because when we first looked at Bifrost, it was working, but it had issues, stability issues, and so on. And then we directly said, okay, we will use Bifrost as part of our infra. We must ensure that whoever or whatever is done upstream should pass things in OPNFV as well. And we hooked into Bifrost and we started providing feedback from OPNFV side. And the other important thing about patch set verification is that it is not so valuable to do things or run same type of testing in our side. We need to give different type of feedback. If you look at Bifrost Gate, I think it uses Cirrus images to bring up VMs. In our case, we bring up larger VMs with OpenSUSE, CentOS, and Ubuntu, and we see if they are provisioned correctly. So if OPNFV tells this doesn't work, it is relevant. And it is different from what Bifrost runs for their gate. Maybe it passes for Cirrus, but it fails for Ubuntu, for example. So for OpenStack, we started with Bifrost, and we will do similar things for more projects, for example, OpenStack Ansible and some others. For Open Daylight, we start doing similar things with a component called Network, which is heavily used in OPNFV scenarios. And for FIDO, again, we will start with few components because it also depends on how much resources we have. So this is pretty relevant for developers because they get to see the feedback from us directly on Gerrit under their changes. But we also need to compose these scenarios. And for that, we need to find working versions of these components. And in order to achieve that, we will run periodic jobs against tip of master of these projects. For example, we have a service function chaining scenario, which uses OpenStack and OpenDaylight. We must find working versions of these projects or components and then pin them in our repo. So we can basically say, okay, OpenStack Neutron, this SHA works. Nova, this SHA works. For OpenDaylight network, this SHA works. And once we pin those versions, we can then put that scenario on bare metal. Because the things we done left, they are cheaper because they can fail many times. But while you get further away from developers, things become more expensive, they become more slower. So we try to put only the things that are worth putting on bare metal. So here we basically do some kind of promotion from your master branches to OPNFV master. Once we put this composed platform on bare metal as part of our daily loops, we run functional testing and yardstick, which is today's OPNFV release criteria. And we try to find working version of this composed platform using your latest versions. And our expectation is many will arrive here and few will pass from our daily loops. And then the other loop we are setting up now is basically weekly loops. And they will run stress testing, destructive testing, traffic, and so on, weekly tests. And our expectation now is few will arrive there and none of them will pass, because we haven't started providing you feedback yet. And over time, we should start seeing few scenarios getting out of this pipeline. And what is the point of this? Okay, we give developers some working version by running daily jobs. But even though our users want latest versions, they want something that works as well. So by doing this, we want to ensure whatever comes out of this pipeline can be put in lab with relatively higher confidence. So they can put this certain scenario in their lab and try things out and get some more feedback. But if they are braver, they can obviously take daily versions as well, but they should know those things might not work. And the other thing here is, like, we have been talking with OpenStack QA team, for example. Now we are doing some testing here as part of our functional and platform benchmarking testing. We need to ensure we are testing right things. So we need to talk to you guys and learn what kind of testing you want to see in OPNFV. Because you have your CI here, and you get some feedback from third-party CI systems, but they might lack some of the testing. So it is important for us to improve and adjust our testing in our side, so you get feedback for the things you are not testing in your CI. So this is high level, and if we look at how the things would look for a developer, and this is SFC developer, we have a friend named Brady Johnson, and he doesn't code a lot, but I just imagine him here as coder. So that guy gets some kind of new feature request and bug report. And if we think how he would be working is that now SFC works with multiple OpenDaylight components, and they also work with OpenStack components and OpenStack Tecker, for example, OpenStack Neutron, OpenStack Tecker. So they have to work against multiple open source communities. And whatever they change might require changes in other components. So that guy, Brady, makes his changes and patches whatever he needs to patch and deploys this on his machine. That is what we call XCI sandbox. We create this sandbox so developers can deploy things on their machines and see if it works or not, because the definition of CI is basically CI starts on developer workstation, not on Jenkins. So you first need to ensure what you did works on your machine, and then you push it to Gerrit, which gets verified. So once that works, the patches are sent to both OpenStack and OpenDaylight Gerrits, And then we start running some patch set verification for these patches. And this is where I want Zool to support multiple Gerrits. We don't use GitHub, or OpenDaylight doesn't use GitHub. So we need to have ability to have dependency between different patches that might live on different Gerrits. Because if it doesn't exist, this is very hard to achieve, maybe impossible. And once we trigger the job, we provide feedback to Brady in about hours and tell him what happened. And this feedback will be limited to deployment and health check on using virtual machines. We deploy this SFC scenario. We bring up 2 virtual machines on this deployment. We try to SSH them, and we try to ping these virtual machines from each other to see if the basics work. And if the basics work, the developer can go and do whatever else needs to be done. If the thing fails, obviously there is something to fix there, because it worked on his or her machine, but it didn't work on CI. And once the patch gets merged, again, we take this time to our bare metal machines and run daily tests and provide yet another feedback on a daily basis. And then finally, we take this scenario to our stress testing and provide yet another feedback. And this feedback, first feedback is much more relevant to developer himself or herself, but the later feedbacks are more relevant for OPNFV community as a whole and other communities.
Question. On the first patch set verification there, is it possible if I'm running code and I'm uploading it here that I can have tests in that first patch set verification which are actually targeting push patch, not just the high level install? Am I able to submit new patches or new tests with the patch set?
Yeah. You can, yeah. This, patch level feedback. I didn't get your question, so yeah, obviously. So that is basically what we are trying to give to our developers to enable them to innovate things. And while we are doing this, we obviously face many different challenges because it's not easy to bring this type of thing up and running. It is even hard to do this with stable versions. It is much more harder to do this with things coming out of master branches. And few of them, this is just a subset of challenges we had. The quality, things work fine for OpenDaylight, things work fine for OpenStack, but when you put them to our bare metal, they don't work. So yeah, you have CI, those things pass your CI, but they don't pass our CI. So we need to see what kind of gaps you have in your CI and how we can help to fill those gaps so we improve your quality. And the point with XCI is to ensure the communities in this ecosystem move towards the continuous delivery way of working. So we can take any version from your master branches and ensure that version will work in our environment. And if you don't go continuous delivery, we can't go to continuous integration. We are saying we are doing continuous integration now, but it's not true continuous integration. We are just pulling those things down and hoping for the best. And most of the times, worse things happens. And the second thing is the issues with the delivery. We talked to OpenDaylight, they use Nexus, they have RPM. We talked to some other communities, they have Debians, and they use some FTP servers somewhere, for example. And when we look at other communities, they use mailing lists for patches. So the things, patches or artifacts, they are provided in different ways. And it is impossible to support all these different means of patching things or producing and storing software. So delivery is another problem. And we started improving things for OpenDaylight, and for OpenStack, we directly went to source code. So for OpenDaylight and OpenStack, things are a bit better. But for other communities, we have things to do. And the other issue is when you start talking about these things, you always end up with talking about tools, because everyone has their own favorite tool. And when you say we need to install OpenStack, the answer we get, why not use this installer? When we say we need to test this thing, we get another question, why not use this framework? And we always end up in tooling and we lose the essence of the problem. We need to get this thing on bare metal and test it. How you do that is important, but it shouldn't dictate us what we can do. So we need to find out what we need to do, and then pick the right tooling there. And the most important thing is obviously the mindset. It is very hard to come to an agreement regarding how to do things, because again, it's related with many different things. Tooling, past experiences, the environment the people are working with, and these all impact our conversations, and we always get stuck in endless discussions, and it slows us down. And because of that, as I mentioned, we create this new track in OPNFV called latest track, and we don't basically, okay guys, what you say is good, but we are trying things. If this doesn't work, we move on to the next thing. If that doesn't work, we work with something else. So it is basically, we need to change how we see things, how we do things, and ensure we are always moving forward rather than just idling and discussing and fighting and arguing with each other. So this is the biggest thing we have been having. And since I mentioned, we must talk about tools as well. Bifrost, we are using Bifrost for provisioning our virtual machines and bare metal machines. Why Bifrost? It is rock solid. It supports Ubuntu, CentOS, OpenSUSE. It is Ansible based, and it's used by many other communities or companies or people. The second tool we picked is OpenStack Ansible. The reason for that is it supports source-based deployments, which is very important for developers because they need source code to develop, and OpenStack Ansible allows you to deploy what you patched on your computer. Apart from that, it supports three distributions, Ubuntu, CentOS, and OpenSUSE, and it's also Ansible-based. So we have two Ansibles there. And finally, we haven't started with Zool, but we want to start a prototype in OPNFV and later on in Linux Foundation, hopefully. So we use Zool for gating in OPNFV initially. And when you look at these tools and their capabilities, they are pretty powerful. But the other thing I want to mention here is that we have developers working in OPNFV, we have developers working in OpenDaylight and OpenStack. And if you ask those developers to look at feedback from Jenkins or Zool or something else, it is very hard for them to switch the context and move between communities. And if we align on tooling level and if we give them same feeling, same type of feedback across different communities, it will be very easy for those people to work in different communities. It should be transparent. It should be like water. They should just flow wherever they need to flow. And that is what we are aiming. I don't know if we will be successful, but we will try, and hopefully with the help from you, and bring these communities together in the end, hopefully. So this is kind of our journey, and what else we are thinking of doing. Alignment is pretty important. Okay, we can't enforce things on different communities, but we can at least start talking in same language. We can at least start calling things in same way. If we don't speak in same language, it will be very hard to come to a conclusion. So we need to start talking about what we are hoping and thinking and trying to do. And then once we get an alignment socially, culturally, mindset level, then we can think about aligning tools. The second thing, cross-community test strategy. We need to find out who should be doing what and who is testing what, and come up with right test strategy so the testing we do is valuable for you and other communities, rather than just for us. The third thing is reaching out to other communities. We have been talking to OpenStack, obviously, to OpenDaylight, FIDO, ONUP, and we will reach out to CNCF, for example, or DPDK, and see how we can include them in XCI. And finally, this is just, I added it today, and explore synergies with OpenLab initiative. So, because what I understand from OpenLab is it tries to enter this fun and challenging arena, and we can maybe collaborate and help each other, and rather than both of these communities trying to solve things alone, we can come together and solve it once and for all, and help everyone, not just OpenStack or OPNFV, but the rest of the ecosystem. So that was all. I hope I didn't bore you to that. It's very long story, and it's very hard to talk about this thing in 40 minutes because there are lots of details, it's very tiring because working in a single community is tiring, but working with 10 different communities is like, it's fun, but sometimes you just want to, okay, I go for a long leave. Any questions, comments?
Can the user communities that are sharing, that exist in multiple contexts help in reducing the drift or divergence? In other words, it's obvious for a tester, it's very difficult for a developer. But what cloud do you have? I mean, the end users are the people who really...
Yeah. Now, I'm not so knowledgeable about OpenStack user community or user group, but in OPNFV we have an user advisory group who provides input to OPNFV community regarding what type of testing they want to see. For example, lately containers or cloud native or that type of stuff, and upgrade testing type of stuff is pretty hot in OPNFV because we are getting those questions from our end user advisory group that is composed by operators, AT&T, China Mobile, and so on. So that is our way to bring their needs into our work and incorporate those type of testing into what we do. And probably OpenStack has similar thing. And I hope these groups are talking to each other some way. XCI is not limited to what I explained here. It can be used and abused in different ways, and that is one of the things we can look and incorporate those things into it. So it's basically the things we are doing right now is based on what we experienced. And if we experience or get requests like what you said right now, we can include that into XCI or OpenLab or whatever the new name could be if we work together and provide that type of benefits to entire ecosystem. So we don't have any boundaries, borders in XCI. That is what I want to say here. Okay, today we are using these tools. Tomorrow we might be using something else because these tools lack these things. We pick another tool to try out new things. For example, Keynote, OpenStack Helm, live upgrade and upgrade tests are important. We might look into OpenStack Helm and include it in this one and use it for that purpose and something else for something else. So that is very important. We don't have any religious things or hard dependencies on these things. I think next session will start. Okay.
I saw Open Contrail on one of your slides. Have you also incorporated that?
Yeah, Open Contrail, I visited their infra call 2 weeks ago. I think Open Contrail is going through restructuring of their infra and continuous integration stuff. So I presented XCI to infra working group of Open Contrail, and they said, give us 1 or 2 months, and then we will come back to you. So they, hopefully, January, we should start seeing Open Contrail there.
About OPNFV in general and Open Contrail support, how is it? I can hear your Boston talk as well, and Contrail was kind of...
Yeah, Open Contrail was part of our 2nd or 3rd release, but then it disappeared, and now we want it to come back. Same with ONOS. We are talking with ONOS community as well, and bring them back and make them part of XCI. So I haven't listed all the communities we are talking to because some of them are just talks, the other ones are more real. Oh, thank you all, and hopefully we can make this better. We just started something and we want to make this even better. Thanks.